This video is to discuss the ideas of being able to prove that lines are parallel. So in this case, I am not telling you the lines are parallel or not. You have to make the decision based off of specific criteria whether they are parallel. So in order to make that determination, you first, again, need to be able to identify angle pair relationships and whether they should be complementary or congruent. So we recognize, hopefully, that our corresponding angles must be congruent if my lines are to be parallel. Alternate exterior are congruent. Alternate interior are congruent. A list of those types of angles, or those angle pairs. Corresponding angles, remember, is in the same location at two separate intersections. So angle 1 is in the top left. It corresponds to angle 5. Angle 1 and angle 5 are corresponding. Angle 2 corresponds with angle 8. Angle 3 corresponds with angle 7. And angle 4 corresponds with angle 6. If I can show that those angles are congruent, then I know my lines are parallel. Alternate exterior would be angles 1 with angle 7 and angles 2 with angle 6. If those two angles are congruent, or those two angles are congruent, then my alternate exterior angles are congruent and my lines are parallel. Alternate interior being angle 3 with angle 5, or angle 4 with angle 8. Okay, those three angle pair relationships would need to be shown to be congruent to prove that the lines are parallel. Same side exterior, same side interior, those angle pairs would need to be supplementary, meaning they add to 180 degrees. Same side exterior would be angles 1 with angle 7. No, that's alternate. 1 with 6. Those are on the same side. Or angle 2 with angle 7. And then same side interior would also be supplementary. Okay, so that would be angle 3 with angle 8. Or angle 4 with angle 5. Now, that begs the question, what about vertical angles and linear pairs? And it's true, vertical angles are congruent, linear pairs are supplementary. But that does not prove lines are parallel. Remember, I have vertical angles and linear pair with one intersection. There's no parallel lines here. These occur at one intersection. The others that we just talked about occur at two intersections. That's the major difference. That's why these cannot tell me anything about whether my lines are parallel or not, because I only need two lines to show this. I don't have a transversal. So let's look at a couple application type problems here. If I want you to decide whether line A is parallel to line B, and if so, explain why, you're looking at, in this case, these angles. If I look at this angle, that's 30 degrees, and this angle, that's 30 degrees. These angles are congruent. I need to make sure that they are one of my congruent property angle pairs. And in this case, those are corresponding angles. They're both located in the same location, top left. Since corresponding angles are congruent, I can conclude that A is parallel to B. Think back to our laws of logic. If corresponding angles are congruent, then my lines are parallel. I've given you corresponding angles are congruent. That is specifically the law of detachment. I have the exact hypothesis, I can make the exact same conclusion. In part B, things are a little different. I do have that this is 100 and this is 100, but those are vertical angles. Vertical angles do not allow me to make any conclusion. Okay. These angles are not congruent, but they are same side interior angles. If my same side interior angles are supplementary, then I can conclude that my two lines are parallel. But in this case, they add up to 175 degrees, which is not supplementary. So I can specifically conclude that since same side interior angles are not supplementary, I can conclude that A is not parallel to B. Again, if this was 80 degrees and that was 100, then yes, then those are same side interior angles are supplementary. My two lines are parallel. The last type of problem is an algebra application type problem. And here, I want to know what value of x would make this parallel. I treat this problem as if they are parallel. If these two lines were parallel, then these two angles, my alternate interior angles, would need to be congruent. I don't know if they are parallel, but if I want them to be, those would have to be congruent. So I'm going to set the angles equal to each other. 12x plus 5 equals 8x plus 33. If I were given same side interior, I'd add them and set them equal to 180. Same side exterior, I'd add them and set them equal to 180. In this case, it's just a matter of solving for x now. Subtract 8x from both sides. Subtract 5 from both sides. Divide by 4. And x equals 7. Now I know that if x were 7, my lines would be parallel. If x were anything but 7, my lines are not parallel.